Okay, good morning. Oh, just exactly 12, it is the afternoon, right? Good afternoon, everyone. We'll have a very short lesson today on video. Okay, on live, online. So, 陳許廷同學家，you here?
Yes,
Yep.
I'm here.
Thank you. 鄧家傑、何偉林。
喺度。
鄧家傑、何偉林。何偉林 here. How about 鄧家傑？林俊軒、林定航。
喺度。
入。
喺度嘅。
OK， 李佩恒、鄧俊軒。
喺度。
How about 鄧俊軒？
喺度。
OK。鄧浩俊、黃俊熙。
喺度。
你好。
黃奕朗、謝學明。
Hello.
Here.
張思維、馮家謙。
Hello.
OK。何孝日、何麗妍。
喺度。
OK。郭俊熙、羅康力。
Hello.
Hi.
OK。李晴、梁家傑。
Hello.
How about 梁家傑？Are you here？梁家傑。李澤星、李傑樂。馬家樂、吳漢一。
Hello。
魏俊滔。
喺個 chat 度。
OK。譚君柔、黃成軒。
喺度。
Okay, so we will start the lesson today. Something more about the bonding structure. Maybe some of you may feel a little bit scared about this. And we just mentioned something about the form of molecules, okay? So molecules, well, so what is that? It is a basic unit of the substances found, very simple, or we call it a simple molecule. So among them, we have got two main different structure. So one of them we call it a giant structure, the other one we call it as a simple structure. So what it means by simple, right, is that, for example, if you have got that four, okay, so you may know that four substances, they would have their own different structure. Now, for example, this one, we call that giant ionic structure for sodium chloride crystal. And how about the others? We'll call it giant covalent, giant metallic, as well as finally, it is the simple molecular structure. So today, we will focus on the simple molecular structure instead. Okay, simple molecular structure. This one, okay, we will focus on this. And iodine is just one of the examples. So whenever I see iodine here, right, you may see they will show you a formula for iodine. Do you know the formula of iodine? If I talk it as iodine solid. So what is the symbol? Do you know what is the symbol? Wen Yalong, do you know? If I want to express the structure of iodine, usually how would you present?
I 一條橫線啫 I
Just I.
I2
Indeed, if you talk about its molecule, we call it I2 instead of I. Okay, because we try to talk about solid. So what is mean by which means that at their own stable state at room temperature and pressure, those atoms, right, they would combine it to form a diatomic molecule. Okay, similarly, we will talk it as something like nitrogen, oxygen gas. Okay, so whenever I talk about as nitrogen gas, we tell it as N2 instead of N. Oxygen gas, which tells you O2. So which means that the atoms, they would join together to form small molecules at their room temperature and pressure. So if you want to talk about the halogens, group 7 as example, we have got fluorine, chlorine, bromine, and iodine. So we have got that four. Of course, we have got acetylene, etc. So we focus on that first four first. How about fluorine? Fluorine is the gas, so we will mark it as G. Chlorine is a gas, we call it G. Bromine is liquid, L. For solid, it is for iodine. Irrespective of the physical stage, we focus on how those atoms join together. Now, so what does mean by the nitrogen? Nitrogen, which means that we have got this as a basic unit. Which one? We have got two balls. One ball represents one nitrogen atom, while the bond that connects, right, that connect the two is by what? Covalent bond. Okay, is by covalent bond. And similarly, for oxygen, is also we've got two balls. Fluorine, chlorine, bromine, iodine is very similar. Okay, and all those data are connected by the covalent bond. Covalent bond formed between the atoms. Okay, this is what you may know it as an element. Okay, so non-metal elements. But if you want to talk about some most non-metal compounds, right? So you may find they will form a simple molecular structure. Now, for example, ammonia, NH3, water, H2O, carbon dioxide, CO2. While those, they will represent something else. Okay, they will represent something else. So it is the matter of a difference in the number of the atoms found inside the molecules. Okay, so altogether, we will call that 分子 molecules. It tells you a basic unit of those to show how the atoms are connected to each other at certain condition. Okay, so normally we would describe it as a type of RTP. Okay, room temperature and pressure. Usually we would talk it as RTP. So in our indeed in our Earth, we will also found those, right? While this structure is not giant structure because it gives you a definite number of the atoms connected to each other. Now, for example, H2O, we have got 3 atoms only. Ammonia, we have got 4 atoms only, but not an extended network. Okay, but it's not an extended network. So we will call that a simple molecular structure instead of giant structure. Okay, so this is first thing I would like to talk to you about the word simple, 簡單結構. So simple structure would always relate to some definite number of those particles that connect, as reflected in the formula. Okay, is that clear? So if you say that it is a simple molecule, for example, if you talk about 葡萄糖, okay, 葡萄糖 glucose, Glucose. So what is the formula of glucose? You still remember? So what is glucose?
係咪 C6H12O6 啊？
Yeah. That's right. It's C6H12O6. So altogether, we have got 24 atoms there. But that 24 atoms, they will make a big substance, a big molecule. So we still categorize it showing a simple molecular structure. Okay, do you know why? Because we still have the definite number of atoms that make up that molecule. Now, instead of giant structure, it is an infinite. Okay, infinite amount of the infinite number of the particles that make it as a lattice. So we would have it. Even though we talk about last time we talked about C70, right? It is also a type of molecule, but this time the molecule is a bigger one. So we will say we will have 70 carbon atoms, okay, that are connected to each other to form a bigger molecule, but still simple molecular structure. Okay, so what is so special about a simple molecular structure? Well, we have got two types of attraction force that connect to each other. Now, take a look on this example, and you can get what I mean. Now, we have got two types of force. One is this one. Of course, we know it is a covalent bond, which connected between atoms. Okay, so this force and the other force, we will call it a type of intermolecular force. 分子間引力. So what does it mean by intermolecular? Okay, which means molecule and molecule in between. So we call it inter. Okay, intermolecular force. Now from the graph, can anyone suggest the relative strength of those two attraction force? Which one is stronger? Which one is weaker? And tell me your understanding or reason. Lê Bùi Hằng.
Covalent bond is stronger.
Why you think that is stronger bond? From the diagram, any hint that you know it is a stronger bond?
The atom in the molecules is closer, but the length between the molecules is
will be at a longer distance, right? You mean?
yes.
Yeah. So you may, yes, that's right. You may you are going to take a look based on the relative distance between them. So the shorter distance, so you may find that the attraction force is a stronger one. Now, so you may find that covalent bond is a stronger bond when you compare with intermolecular force, which is weaker bond. So we may have got a very special name. We talk about intermolecular force. What is that? We call that van der Waals force. So they for the time being, we are talking about the same thing. Now, of course, the more you know, later on that you know that intermolecular force is just a general term. There are so many different types of intermolecular force. Van der Waals force is just one of them. We have got another type, which is hydrogen bond. Okay, have you ever heard of the word hydrogen bond? So we will have it later. I will have that coverage of it later. Okay, so we have got two types of intermolecular hydrogen bond, intermolecular force. What is van der Waals force? Much weaker force. Hydrogen bond a little bit strong, but still weaker than covalent bond. Okay, so we have got that too. So don't worry about that too. This one for the time being, you will know it later. Okay, so we have got two forces, right? One is a weak force, attraction force. The other one is a strong bond. So whenever you talk about bond, it is always related to the word strong. Okay, remember. Okay, whenever you see the word bond, something strong. Questions? Now you take a look on this diagram. This one, please put a star here, and you need to draw. If you're asked to draw so what is that? If you are going to draw it as a structure of iodine, so what structure do you find? Yeah, a framework very similar to sodium chloride, isn't it? Right, very similar. It seems like dice with 6 faces. But if you take a look at the dice, it seems like having 1, 2, 3, 4, 5. Okay, 5 boards with 1 at the center, the other 4 at the corners, like this. So whenever you see the 6 faces, right, they will have such a arrangement like this. Can you get my point? Now, I do hope this will help you draw that diagram successfully in the quiz. So again, do you find any van der Waals force and covalent bond? So you may have covalent bond, right? Still the same. Where is it? Where will you find covalent bond? Can you tell me the covalent bond, van der Waals force? Where can you find such?
The iodine molecule between them.
Between them. So what is that? Is it van der Waals force or covalent bond between molecules? So what is mean by between? Between is something like this, okay? So it is having a magnifying glass to have such between them. Okay, just like this one, these two between them. Okay, so what is that? Is it van der Waals force or covalent bond? The one I draw in a dotted line.
Intermolecular force.
Yep, a type of intermolecular force. So remember, it is a type of weak intermolecular force, which means that it is attraction between molecules. So our common practice is to draw a dotted line. Okay, whenever I draw a dotted line, which means the force is weak. Okay, so how about covalent bond? Where you will find covalent bond? Where you find covalent bond? 譚君柔. Where will you find covalent bond? Hello? Covalent bond, yeah. So strange. Where are you?
I don't know.
You don't know. In
Yes.
the, so you may see somebody will say that iodine atom, and somebody will say that in iodine molecule. So where you will find the covalent bond? The answer is where?
Between the 2 iodine.
Between the 2 iodine atom. Okay, which means where? Now 2 iodine atom. We have got 1 iodine atom here, 1 iodine atom here. We have got in between, like this. Between the molecule?
No, between the adjacent iodine atom.
Adjacent iodine atom. So which means that you are having the one which is the closest distance. So it is the between iodine atom within the iodine molecule. Can you get my point? So it is within the iodine molecules. We have got that. So we have got the strong covalent bond. So all of you please mark it down. Between the atoms within the iodine molecule. So what this mean by within molecule? So it is just circle the molecule, and we have got two balls sticking to each other. So the glue, okay, the glue it is indeed the covalent bond. So similarly, you may find on the right hand side, it is the covalent bond. Now, can you get my point? So the dotted line, it is the intermolecular force. Van der Waals force is a weak force, but the being between iodine atoms within the molecule, it is made up of strong covalent bond. Okay, is that clear? Got it? So we would take a look on some other structure, right? In order to get to know what is really the case, right? How about this? Dry ice. Dry ice. Dry ice, what is that? Dry ice is a solid form of carbon dioxide. Okay, so we call that Gonding. So this one is different from the normal ice. Do you know? So you know the use of this. Anyone who know the use of this? Lô Hong Lịch, do you know the use of dry ice?
Keep the thing cold.
Yep, keep the things cold is a type of a coolant, a refrigerant. So maybe during the Mid-Autumn Festival, somebody who love to eat some moon cake ice cream. Have you ever heard of that such? So and normally they would be stored, but they will give you you'll be given a very small packet of dry ice, right, while you deliver from one place to another. Okay, so we've got a very small pack. So in between, inside that it is dry ice, which stick on the box. Okay, we stick on the box. So we have got something ice cream inside. Have you ever heard of that? So I have in the past, while there is a increasing use of this dry ice, there have been some accidents before. So some girls, right, who just wears skirts, a very short skirt, and then they just put that a box of ice cream on the thigh. And finally, after sitting for, let's say, 15 to 30 minutes, and they stand up, so what will happen to the thigh? So we have got some burns. Do you know it? Have you ever heard of that? Do you know it? So it is because of the fact that the dry ice is too cold. Okay, it will hurt you. It will hurt your skin. So the skin it is quite sensitive to extreme temperature. If it's too hot, a type of heat burn. Okay, but if it's too cold, we will also tell it as a type of burn. Do you know what? 凍傷啊. So so remember, whenever you take that box, you will find that dry ice packet. Never touch it for long. Okay, never touch it for long. Of course, somebody maybe just like those people of Info Day helpers, right? In the past, you may have ordered some dry ice, right? So somebody would love to touch it, right? But remember, if you touch it for long, what will happen? It's not just a burn, but that dry ice will stick onto your finger. You know what? So whenever you want to take it away, it will be quite difficult. So that's minus 70.5 degrees is this the point where the carbon dioxide gas that would changes its physical state from solid to gas. So what is that? That point we call that a type of sublimation point. Have you ever heard of the term sublimation? 升華, sublimation. So it is a state, we call it a change of state from solid to gas directly, okay, without passing through it as a liquid. Okay, so sublimation, no liquid there, no liquid at the room temperature and pressure. So they will directly go to the gas. So do you mean that, Mr. Chin, CO2 will not exist as liquid state? Zhao Ming, do you know? Do we have liquid CO2?
No, I don't know. I don't think there is liquid CO2.
Okay, so in the world, can we make liquid CO2?
Maybe no.
How? How can we make it? If so, how can we make it? You don't know.
I don't know.
Okay, anyone who knows. How can we make liquid CO2? Indeed, we have got liquid CO2, but you need some special arrangement to make it as liquid. How? How long do you know?
Google 緊。
好似係個壓力要唔好係 RT 咯，即係唔好 room temperature 同埋 pressure 咯。
If you want to make it at room temperature, we need to apply what? Pressure.
Pressure.
Okay? We need to apply pressure. How much pressure do we need? How much pressure? Do you know? More than 5 atm.
5.2 par. 5.2
Yeah.
par.
Which means 5 atm. We need to increase the pressure to 5 atm. At room temperature, increase the pressure to 5 atm. I can change the CO2 as a liquid. Okay, a very strange one. So which means that at 1 atm atmospheric pressure, we will never have any liquid CO2. So remember, that doesn't mean dry ice don't have any liquid, but we can do something in order to make it as a liquid. Now, similarly, it's not just dry ice, but also iodine. Iodine is also a very strange substance which will sublime. Do you know it? Okay, so circle it. It also sublime. So tell me the sublimation temperature. Can you search it on web? And then tell me what is the sublimation temperature? No idea.
184.3 Celsius. 184.
184 degrees Celsius for iodine? You mean for iodine? Really? Sublimation, but not melting. I will look for sublimation. Do you know it?
113.7 Celsius.
Now, you take a look on the 113, you search the web, it tells you it's just a melting point. So melting, which refers to what? Melting, it refers to changes state from solid to liquid. But that type of environment, it would really depends on the condition where we have. So for iodine solid, so they would have their own sublimation. So where it's not just high temperature. It's not just that high temperature. Do you know, at room temperature and pressure, even 30 to 40 degrees, and we will have that sublimation. Do you know? Which means that if I will be given a iodine solid, okay, first of all, do not touch it with bare hands. For example, I will ask you guys to place those iodine crystal into a beaker, and I put a hand just underneath, okay, I cover it with a watch glass. So you cover it for some time. So what will happen? For example, after 1 minute, what will happen? So you may have some green, purple vapor here. While the purple vapor, it is indeed an iodine gas, iodine vapor. So do you know? No need to make it as 113. It is a melting point. Okay, remember for the sublimation, even you use your body temperature and you can sublime some of the iodine. Okay. So this is what you may know about this. A very funny facts. And if you want to compare with some other chemicals, just like hydrogen, oxygen, iodine, and water, what are they in common? What are they in common? Is that when you compare with something about giant structure, they will have a rather low melting point, okay, low boiling point, and usually they would exist as a gas. Okay, sometimes liquid, sometimes solid, but that solid, they will still have low melting point. And second, I would like to share with you is on the solubility. Solubility water, you may find it, even though it's said to be soluble, will have a very slight number. What we describe it, we call that a slightly soluble, but not telling it as soluble. Okay, very, very poor solubility in water. And three, what's next is about the electrical conductivity. So whatever states they are, we will tell it as a non-conductor. So today it's time to take a review of those three properties. First of all, melting point very low. 2, solubility in water is so poor. 3, the poor electrical conductivity. We've got that 3. Okay, so besides, we have also got it as a, if you talk about solid, normally it's a soft, low melting point, low boiling point, slightly soluble, or even insoluble water, do not conduct electricity. But remember the term here, you may see very strange, soluble in non-aqueous solvent. So non-aqueous solvent, I will give you some hint, just like acetone. Have you ever heard of that? Acetone. What is the use of acetone? Or thinner. Have you ever heard of that? Thinner. Do you know what is the use of the use of this? You don't know. So acetone, 丙酮, okay, it's used as a nail polish remover, 洗甲水. While thinner, we call it 天拿水. So why we call it thinner? Do you know? Thinner. Why we call it thinner? If you want
因為
to,
佢將啲嘢去整薄佢咯，所以整佢 thin 啲咯。
yes. So if you want to talk about, for example, if you want to make a paint, okay, you know that the paint will have got water base and also a non-aqueous base. If you find it very, very smelly, normally we will use thinner to further dilute the paint, okay, in order to make it less thick. So what is mean by thinner? It is the chemical which will help those things thin, the liquid thinner. So you in the past, maybe I don't know whether or not you have that experience before. Anyone who have in a primary school kids will have got that type of corrosion fluid. Have you ever seen that of corrosion fluid like this?
Very smelly.
Yeah, very smelly. So you open that with got a brush, and it's used. It seems like a paint, a white paint which covers the words, the wrong words, and then you let it dry such that you can write on something, write on those white paint again. So it is a type of correction fluid. 一啲嘅塗改液啊。So it's a very old type. So once you use it for a long time, what will happen? It will become a solid, right? Or it will become too sticky. Too sticky that you will find it quite difficult to apply it to have a painting over so long words. So whenever you buy the correction fluid, so what will be given? We've we've got a pair of another liquid. While the another liquid with the black cap, it is indeed thinner. Do you know it? Have you ever heard of that such? Now, next time while you go to the bookstore, go to the stationery part, you may find, maybe you still can find such. They work as a pair, right? The one on the left-hand side is used to cover the warmers. The one on the right-hand side, it helps dissolve those solid paint back to liquid. Okay, and if it's too sticky, I can do it to make it less sticky. If it's less sticky, the paint applied will not be so thick. Okay, if it's less sticky, it will be something like this. So we will call that thinner. Okay, you get what I mean? So let's have a look of the hardness. Now, if you say that is if you are going to tell it as hard or soft, normally we are going to do what? We are going to do something to overcome the attraction force. So we have got two types of attraction force. Which one should be overcome first? The weak one or the strong one? The weak one or the strong one?
Weak.
Why? Why would you choose to separate the weak attraction force instead of a strong force? If you talk it as a testing as hardness, why not? Why not break it as strong force? First of all, instead I break down the weak one. So what is mean by the strong force, strong bond? In order, what is mean by hardness? Or you're talking about soft for another one. If I tell it as soft, which means that the material inside the particles would change its position very easily. So if I would do such, what will happen? I need to relocate, for example, like this. We need to overcome certain type of attraction. Can you get my point? So it depends on what is the attraction between the particles. So we have got two forces. One is weak, one is strong. Of course, weak force will be overcome first because it would have less effort, and then you can overcome. But for strong bond, sorry, you need much larger force or higher energy in order to overcome. So remember, whenever we've got weak force and a strong force together, okay, so what will happen is that some weak force will be overcome first. Can you get my point? Now, second, how about melting point and boiling point? Again, you are going to overcome what? The weak attraction force during melting and boiling. Okay? So, but remember, the covalent bond here will not be broken in the process, okay? So, if you just focus on overcoming weak intermolecular force, you just need little heat, okay? If you use little heat, is need to overcome the attraction forces between the molecules and separate it. So we will call that they have a low melting point and boiling point. Okay, so they will help you explain why simple molecular substances, they are liquid or gas at room temperature. Even though you talk it as solid, they still have a very low melting point. If you do not understand it, okay, I can give you one more analogy. So what is mean by heat? Now just imagine, you and your so-called best friend, you describe it in front of brother, right? They will go to the cinema. Now, I know that some of you love to do so, right? At the same time, you ask for some other brothers that go to and to accompany with their own best friend to go to the cinema, right? Such you love to sit in pairs, right? Sit in pairs in the cinema. All in a sudden, okay, there is a fire alarm. Okay, so what should you do? Of course, you need to go away, right? You need to evacuate. You need to do something like fire drill. You need to escape the scene. So what should you do? You are just holding your hands tightly with your best friend and then go, or will you also escape? Okay, go with your friends together. Can you get my point? Of course not. So what is the hidden message? If you want to have a fire alarm, okay, it is a type of heat, right? It's a type of excitation. And whenever you are going to leave, so what should you do? Is to leave it like this. Is to leave it like this. Is to leave it like this. But not that two separate. Okay, but not separated. Can you get my point?黃奕朗嗰啲應該明喎呢啲。You have such an experience. So remember, whenever you talk about the heating, you are going to overcome. You may see that even though you have got two types of attraction force exists. One is something weak. One is something strong. So whenever you are going to have an increase of energy, okay, remember the first thing is, okay, the weak force will be overcome. First of all, while keeping the strong bond still there. So that's why if you want to talk about carbon dioxide gas, it is still CO2, but not directly separate into one carbon and two oxygen atom, okay, in gaseous form. No, we will have this in the gaseous form, CO2. So you may see how strong those atoms, they are connected to each other. So second, whenever you're going to talk about change in state, the chemical inside, the chemical nature is still have no change. Do you understand? Okay. So how about the solubility and electrical conductivity? Now, you may find it as let's have something a little bit more challenging. Solubility. Solubility 溶解度. Solubility, if you are going to talk about how well the solute, they will dissolve in solvent. So you may have heard of these terms, solute, solvent, solution, right, in Form 1. So indeed, water is a common solvent, but it is not just water to act as a solvent. In chemistry, we would use the term aqueous or non-aqueous solvents to distinguish one from another. So first of all, some factual information. The one which have a simple molecular structure, they are usually soluble in non-aqueous solvent, but slightly soluble even in soybean water. That is the first fact I would like to draw attention. For example, this one, cyclohexane, okay, 環. Cyclo means a type of ring, 幾遠. So it is a type of a compound without water, that is non-aqueous solvent, it's a liquid. It is rather smelly, so when I put the iodine inside that, it is very soluble in those organic aqueous, non-aqueous solvent, or we call it organic solvent. 有機溶劑。We also talk it as this, but slightly soluble in water. Why? Why is it like that? So indeed, if you are going to talk about solubility, you need to consider the attraction forces that exist between different types of molecules. Now you take a look on these three types of model. Now can you elaborate how come iodine would be soluble in water? Now first of all, between iodine, they are making of van der Waals. Okay, between iodine molecules. How about between the sulfur molecules? It is also helped by van der Waals. How about between iodine molecule and cyclohexane molecule? It is also made up by the van der Waals. So which means that when what combination they have, the attraction force, they are much the same. They are in the pure substances. Okay, that what is that attraction force we're looking for? If you are going to talk about solution, you are going to talk about attraction force between the molecules of iodine and high cyclohexane. They are much the same and that of the more pure substances. So what is the consequence? The consequence is that the iodine molecules and cyclohexane molecules, they will mix together easily. So this is a type of a mixing of the solute and solvent to form a solution. So of course, that type of phenomenon, we call that it is soluble. Can you get my point? So the force between them, no matter in the pure state, pure substances, but also while you are having a solution with solvent and solute in between, they are of similar strength. The strength they are of similar. They are similar, so they can mix together. So we will call that type of phenomenon. Have you ever heard of that? Like dissolved light. Have you ever heard of that phenomenon? Like dissolved light. So like it here doesn't mean love, right? It seems like alike. It tells something like alike. 相似嘅嘢. Or in Chinese, what we will call it is 物以類聚. Have you ever heard of this term? Now, which means that for those of something similar, they will go it together. Can you get the point? So that's why iodine can dissolve in non-aqueous solvent. Remember, because being between the aqueous solvent is still held by van der Waals, and when you try to get mix of the two, solvent and solute, they are also held by the van der Waals, which is the similar strength as in pure substance. How about when I force the iodine to dissolve in water? That is another case, okay? Iodine molecules in between them, they are just weak attraction force. Okay? How about between water? Between water, that type of force is rather strong. Now, even though I talk it as a type of intermolecular force, but indeed that type of force, it is indeed hydrogen bond. Okay? The hydrogen bond between water molecules, which is a little bit stronger than that. So that's why if you want to talk about water, we usually deal with the high surface tension. 表面張力, have you ever heard of that? So it seems like a coin. Now I would like to put a drop of water onto that and try to add further drops. For example, $5 coin. Now after today's lesson, you may you may at home and try to pick up one $5 coin and try to drop the water drop by drop onto the coin and try to see how many drops of water it can withstand, but before those water they will splash off, they will drain, they will go away. I've done that experiment before. It is more than 40 drops. More than 40 drops of water it can hold. So we will say that the water molecule inside, they are held by some strong force. What the strong force? It is hydrogen bond. But for the in between iodine, what is that? It is a type of weak intermolecular force. While that weak intermolecular force, it is just van der Waals force. So if I'm going to force to get a mixing of the two, you would have what? A rather weak attraction force between iodine molecules and water molecules. So which means that the iodine cannot go into the space between water, because the hydrogen bond between the water molecules, they are too strong to overcome. So into the saying, we may need to write down this. There is a little interaction between molecules of iodine water. While the attraction force among water is strong, which is in terms of hydrogen bond. But the force between iodine molecules and water molecules are weaker. So water molecules tend to stick together rather than allowing iodine molecules to come between them. So they cannot mix well. Or if you want to say it in another way around, the attraction force between molecules, they are too strong to be overcome by the iodine. So they cannot mix well. So again, 物以類聚. So you may find that they are of similar strength, they will go together. While the particles with a similar strength, which is rather strong, they will also come together. If I intentionally get mix of the two, sorry, they will finally go back to their own position. Okay, they will stay with their neighbors instead of some newcomers. Can you get the whole flow? So it is what we talk about it as iodine not so soluble in water. Any questions? But wait a minute, Mr. Chin. I heard of iodine solution in the lab. So how can we make the iodine solution in the lab? If you say that iodine solid cannot dissolve in water, how can we make iodine solution? Just recall your memory for those people I'm looking for somebody who is observant. Cyrus?
Yes.
Yeah, how can we produce iodine solution? If I tell you the fact that iodine solid does not dissolve in water, how can you make such? Do you know? Instead of dissolving in water, it dissolves in some other thing else. Do you know? The soulmate stop what?
Cyclohexane.
No, but you will say it as AQ. Potassium iodide. So that is the answer, okay? The I2 dissolve in Ki. Why will it so become highly soluble? It's because of iodine. When I come to iodide, they will form a very strange substance. We call it triiodide. While it is somewhat more stable. So indeed, if I want to dissolve iodine in the aqueous solution, you may need to have potassium iodide. Now, potassium iodide, whenever I see AQ, which means water as a solvent. But this time, that solution, I use that solution to make as a solvent to dissolve in I2. Now, very strange. Okay, so this is what I would like to share with you here. What is the color of iodine solution? Now it's time to write down those information. I2 solid, I2 liquid, no liquid, it's gas, I2AQ, and also I2 in organic solvent. Do you know what we have got 4 different colors? Okay, so all of you could you please mark it down. First of all, iodine solid. It is somewhat black. It's a black solid. Iodine gas, it is in terms of purple vapor. Iodine AQ, a brown solution. And iodine in organic solvent, it is somewhat purple. Okay, so when we meet, I would like to show you this one as well. We've got 4 different color talking about iodine. Any questions? But before I end up the lecture about electrical conductivity, I'm sure you will know how to answer. Simple molecular substances do not contain mobile ions nor delocalized electrons. No, they do not contain mobile ions or delocalized electrons, so they cannot conduct electricity. All electrons, they are involved in the bonding, nor as an unbonded, we call it lone pair. While the electrons, they are just localized within the atom, so they cannot conduct electricity. And so much for today's lecture. How about this? Class practice 9.3. Now this one, I would like to do it later, okay? Because you talk about another substance, which is silicon dioxide. It is in form of a giant covalent structure. Now I would like to do some MCs as a closure. Just 3 MCs. Take a look. Let me see. MC question 7. Take a look. MC question 7. Now this is the one. Which of the following statements, okay, describe the attraction forces between the molecules? Now this is the MCs removing that. Between molecules, they are weak force formed between the covalently bonded molecules. Okay, the answer is C. Whenever you talk about molecules, we don't want to talk about hold the molecules together. Okay, no. Hold atoms in the molecules is not correct. Strong ion bond, no such. Hold ions is not correct. Okay, question 7. Okay, the answer is C. Now you take a look on some other questions. On question 9, 10, and 14. Okay, question 9, 10, and 14. And try to see if you can manage 10, 9, and 14. 10, take a look on this. Which of the following, can you see that? Which of the following describes the appearance of iodine in the stated condition? I just told you. Solid, which is black. How about dissolving cyclohexane? It is said as cyclohexane is a type of organic solvent, so it is said as a purple. Okay, the answer is C. How about number 10? Number 10, and then let's see the next question. It is question 9. I'll just skip that. Question 9. Neon exists as a gas at the room temperature and pressure because. Do you know how to answer this? Now, whenever you talk about this, now even though it is a neon, it is a monoatomic molecule, okay? Monoatomic. We still have some attraction force. So what is that? What is that attraction force? It is still, we call that as a intermolecular force in terms of van der Waals force. Okay, we still have such. Van der Waals force is a weak force, so you may need to take a look on the answer. Now, this is the fact. This is a fact. This is also a fact. It's also a fact. But you need to talk about because. Okay, so if you want to talk about as gas, which we lays that they have a very low boiling point. So which means that very little heat is enough to overcome the van der Waals force. So the answer is C. Can you get a point? So you are going to relate the physical property by its bonding and structure. This time, the weaker force will be sacrificed first. Okay. Remember, every time you are going to overcome, it comes to the weak force first. Van der Waals force. And finally, you take a look on question 14. Which of the following exists as a discrete molecule? Discrete molecule. 獨立個體嘅, okay? Separate molecules. So take a look. Simple structure. Which one has a simple structure? The answer is, now this one, it is in terms of a giant metallic structure. No. Graphite, it is in terms of a giant covalent structure. You will know it next in the next lesson. How about oxygen? Yeah, this is C, okay? Silicon is also a type of a giant covalent structure. And you will know it, B and D, that too are later. Okay? What you feel about today's lesson? You may find it quite difficult. So when we meet, okay, it's time to take a look more on the simple molecular structure as well as the giant covalent structure. We have got Wednesday as well as next Tuesday. Okay, we've got 2 more lessons to go, and we will try to finish them all. Any questions so far? Now I will give you some exercise, right, to try it out. The one about simple molecular structure. Now remember, today we have got a homework assignment due today. Okay, please check your Google Classroom. And also this Wednesday, we have got a quiz on metallic structure. We will do it weekly. Remember, the quiz will be done weekly. So do grab the time and try to learn as much as you can. Now you may see the whole flow, the logic is very, very similar. It's a matter of changing, okay, of some other substances. Okay, questions? Now, if not, I'll just stop here and see you guys this Wednesday. Bye-bye.